Today we had to learn about other devices. First, I would like to introduce about type of multi-vibrator. Vibrators are a group of regenerative circuits that are used extensively in timing application, and there are four kinds of stage. First is astable, which is not stable and no stable stage in them. And second is monostable, and there is only one stable state. Bistable is bistable has two stable states. And next we have to learn about relaxation oscillator. Relaxation oscillator is a non-linear electronic oscillator that produces a non-sinusoidal output signal such as a triangular or square wave. As you can see in this graph, we call this section as PDR, and as the current is decreases, we can guess in this point the resistance is gonna be lies, and the red line is we call this area NDD, and this state is stable state. And next we have learned about logic memory application. The operation of the delayed flip-flop is based on two RTD in a circuit called the monostable bistable transition logic element. The intersection of the two graph here we call the stable state. So we can see the stable state here, and for bistable there is a two stable here, but this is more lower energy, so the stable is here. And this is for if the voltage bias voltage is smaller than 2 times of the voltage peak, we call this state as monostable. And if the bias voltage is larger than the 2 times of peak voltage, we call this state as bistable. Yeah, this is same that I talked previous. And for the lead date, we can know whether it's low or high. And for multi-valued logic, we can define several numeral logic stage at one times. And as you can see in this diagram, there is a two NDR point here and here, and which is not NDR in there. There is 3 points, which here described as A point, B point, and C point. And at this point we can use multi-valued logic. And for next, we have learned about transistor scaling down. Need lower supply voltage to lower switching energy. The maximum energy is equal to CVDD square. But performance suffers when supply voltage is scaled in CMOS. And nowadays we have limitation to reduce the gate capacitance, so we try to reduce dynamic power consumption. Better performance is required for ultra low power application. And as you can see in this graph, we had succeed to reduce the supply voltage, but it is really hard to reduce the threshold voltage. And if the subthreshold swing is smaller than 60 millivolt per decade, the step will gonna be very good. So this will react as like a good device. And if the subthreshold is near to the 60 millivolt per decade, we use this for TFET. And for next, we have learned about subthreshold swing. For this section, we have to know the ideal factor M. If the ideal factor is getting larger, we have to use more current, so it will be very bad if the ideal factor M is getting larger. It is very good for if the ideal factor is equal to 1. Yes, it was my last week's lectures preview, and thank you for listening.